Okay, we're back, guys. So for number 7, we'll be looking at two forces F1 and F2 that act on a particle. We know that the force F1 is given by this equation, which is F1 equals minus I plus 2j newtons, so that's the value of the force. And we also know that F2 acts in the direction of the vector I plus j. Okay, what does the statement mean? This means that F2 is pretty much parallel to I plus j, but somewhere on another position. So we could say, for example, that I plus j is over here. So this is definitely I. You move an I across, one I and another j up here. So this is I plus j. This implies that for the same movement, we also have something called F2. So notice that these two are moving the same. That's what it means here. So this implies that F2 must be some scale factor bigger than I plus j. That's all you need to know for direction of motion. It's always a scale factor bigger than its other motion. So it could be less or it could be smaller. I don't know. It could be half I plus half j, 2I plus 2j. We don't know, so we call it ki plus kj. Okay, so that's our vector F2. We also know that given that the resultant force of F1, F2 acts in the direction of the vector I plus 3j. So again, in fact, this is the same thing. So now we're going to have another vector. We know that the direction is I plus 3j. So how does I plus 3j look? It's like this. It's like 1 across and then 3 up. So something like this. Let's call this I plus 3j. And we know that F1 plus F2 also moves in that direction. So we'll call this F1 plus F2. And therefore that means F1 plus F2 must equal some scale factor, let's call it C this time, of I plus 3j. Easy. And now if you think about it, we have an equation, we can just plug in, and here they want us to find, of course, F2. So technically we just have to find this value by plugging in what we know of F1, what we know of F2, and then solve it simultaneously. So hence, replacing F1, we're going to have minus I plus 2j plus F2, which is now ki plus kj, and all of this equals to ci plus 3cj. What you want to do here is something known as equating coefficients, okay? So what this means, we look at both sides of the equation and we just match them in terms of i's and j's. So we're going to match in terms of the I coefficient. So we look at the left hand side. What do we have on the left side? We have negative 1 plus k, and this is supposed to equal to c on the right side, so these three. Now equating in terms of j coefficients, what do we have? We've got 2j, so we've got 2 here, plus kj, which is just k, equals on the right side 3c. And voila guys, you just solved this simultaneously. So this is actually the easy part now. So looking at this equation here, these pair of equations, we can simply just subtract, these equations from each other. So subtracting the top from the bottom, we can do minus 1 take away 2 will give us minus 3. K take away k is 0. C take away 3c is minus 2c. And thus c equals, dividing by minus 2 will give us 1.5. And then picking one equation, I'll pick this one up here, the one with minus 1 plus k. So using minus 1 plus k equals c. Replacing c here and adding 1, we're going to have k equals 1 plus c, i.e. 1 plus 1.5 will give us 2.5. Not bad, is it? So therefore, going back to the top, F2 equals k plus 1 I plus j, hence F2 equals 2.5 I plus 2.5 j. That's it, guys. If you guys got this answer, congratulate yourself. Oh, I can't even say the word. Give yourself a big pat on the back and give yourself big congratulations. And again, if you want to discuss any of these problems, how I got this solution, how we can, think in this way, just, drop a comment below, and you guys in a bit. Okay, now part B. So I'm not gonna lie, this question is quite standard, so it's going to be pretty good. So what do we have here? We have the acceleration of p is 3i plus 9j. So let's write down. We've got a equals 3i plus 9j. And we know at time t equals 0, the velocity of p is this. So this means that the initial velocity, we can call this u equals 3I minus 22j. Find the speed of p when t equals 3. So, you know, this is actually pretty straightforward. We want to find the speeds. In other words, we want to find the magnitude of the velocity v at t equals 3. So, really and truly, we just need a Suva equation. So just using Suva for a second, you know, just underline what we need. We don't need s. Our initial velocity is given. We need to find this acceleration and time. So make an equation of these four pairs. And the best one to use is of course v equals u plus at. And that's it, guys. Let's pop this all in. So replacing u, we're gonna have what? We're gonna have 3I minus 22j. Cool. A, which is blah blah 3I plus 9j. And we're gonna multiply this all against 3. So I mean the a part at least. And then simplifying this, what do we get? So we got 3I minus 22j. Multiplying these terms across by 3, you can get 9I plus 27j. Correct my maths if I'm wrong, guys. And voila, the velocity v is going to be 3I plus 9I, which is 12I. Minus 22 plus 27j is plus 5j. And then the speed is always going to be the magnitude, yeah, of v. So therefore, the magnitude of v is just, you know, the Pythagoras technique or the distance formula. So we take the square root of 12 squared plus 5 squared. Inside it should give us, in a calculator, I'm just going to go straight from my head. This should give us 13 meters per second. Work this out and see if you get the same conclusion. But otherwise, guys, hope this video helped, and I shall see you a lot soon. Drop your discussions below. Let me know anything, any questions you want me to tackle. I will get on it ASAP. Ciao, guys, and see you all soon. Bye-bye.